Welcome back. Here we'll get a little bit more practice with this graphical approach to solving polynomial inequalities. Here I have another polynomial inequality. Now I say that because if I move everything over to the left, I subtract 4x squared and 21x, I could write this as x cubed minus 4x squared minus 21x is less than or equal to 0. So here I have my polynomial function on the left and my inequality. I would like to find where this is below or at the x-axis. So that's something to keep in mind as we proceed. Now, I need to know what the graph of this polynomial looks like. So if I think of this as f of x equals x cubed minus 4x squared minus 21x, the most important thing for these types of problems will be to find those x-intercepts. So if I set this equal to 0, then I might want to try to factor. So I notice that every term has an x in it, so I might be able to get an x out at least. I'm left with x squared minus 4x minus 21, and that quadratic is one that we should be able to factor. Thinking of things that multiply to negative 21 and add up to negative 4, I think negative 7 and positive 3 are probably going to be our winners. Alright, so here we have another cubic polynomial, and we found its zeros. We can tell its end behavior is going to be the same as the one that we just saw. It is cubic, so it is going down to the left and up to the right. Now I say down to the left and up to the right because our leading coefficient is positive. Right? This will look something like x cubed. So if I plot all of this information, if I plot my x-intercepts, which I actually have yet to find, this first one implies that x equals 0, this one implies x equals 7, and this one implies x equals negative 3. So we'll come over to negative 3, come over to 7, and we have an x-intercept at 0. And looking at this polynomial, each one of these has a power of 1. Each one of these factors only appears once, so each 0 again has a multiplicity of 1. So we have our end behavior going down to the left, and we will cross at the axis and then swing back down to hit the second x-intercept, crossing again and swinging up. So our graph this time looks fairly similar to the one in the previous problem, but the inequality that we're trying to solve is pretty much the exact opposite. We want to find where this is below or at the x-axis. So our x-intercepts are winners for us, as is the piece of the graph between 0 and 7, and the piece of the graph to the left of negative 3. So if I put that in interval notation, I would say negative infinity up to negative 3. The stuff between negative 3 and 0 doesn't work. Oh, and I need a bracket there because negative 3 is satisfactory. It works in our inequality because at negative 3 our polynomial is 0 and 0 is okay. So I need a bracket for 0 and a bracket for 7.